aqueous solution. We need to write. Okay. So then there are two type of changes that we are going to discuss today. Let's see whether we'll be able to do that or not. But before that, let's check your homework, whether it's correct or incorrect. Did you take some help or do it on yourself, by yourself? You took help? Okay. Like which? Okay, okay. So, okay, okay. So, did you follow the table that I've shared? Nitrate, sulfate, ammoniums. Did you follow that table? It was in the chat. It was in our chat. Can you please look into the chat? I've given you one table for that. Okay. So, so you need to take help from this table. Nitrate. Oh, so, do you want me to do any one for you? Like for practice? Because if you need help, we can like do it now so that it would be more clear to you. Okay. So this is the one table that we need to use. Let's write magnesium nitrate. Let's write magnesium. Do you have your periodic table with you? Okay, please. Okay. Can you tell me the symbol and the charge on magnesium? Is positive too. Okay. So nitrate is not in the periodic table. It must be in this table. Where is nitrate here? NO3, right? Minus 1. Here is nitrate. Okay. So we need to take help from this table while writing this. Okay. Now, when writing a chemical formula, we need to follow certain steps. Our number one step is we need to write symbol and charge. Is it so? Number two is we need to simplify the charge. Okay, is the simplification possible in these charges? It's plus 2 and minus 1. Can these be simplified? No. So we'll write this as it and then we cross multiply without plus minus. Okay? Let's cross multiply. Because there are more number of atoms, so we need to put nitrate into a bracket. Okay? Because we need to write 2 over here from here. Okay? That's why we are putting a bracket over here. And for 1, we do not write 1. It's a rule. We do not write 1. 1 is the understood value. If nothing is present, it means 1 is there. Okay. Let's discuss calcium phosphate. Another one. Can you tell me the symbol and charge of calcium? Good. Ca plus 2. And phosphate? It must be in this table. Uh, Second last. PO4 minus 3. Okay. Can we simplify the charges? No. Now we have to cross multiply. So with Ca, what are we going to write on the bottom? Oh, no. What is, we do not write plus minus. So we have said that we cross multiply without plus minus. Okay. So it would be Ca3. Okay. And shall I put PO4 in bracket? Shall I write this PO4 in bracket? Okay. So PO4 and what shall I write outside the bracket? 2. Look, you know the answer. So this 2 should be here, not here. Done? Are you getting my point? Okay. Let's practice one more. Ammonium sulfide. Ammonium sulfide. Both are here. Both are in the table. What is the formula for ammonium? Yeah, ammonium. It's NH4 plus 1. It's here, right? Okay. Okay, and where is sulfide? Here with the double tick. Okay, so we have to write SO3 minus 2. Can we simplify the charges? No, they are already simplified. Okay, then we just shift it. Shall I write NH4 in a bracket? Do I need to? Yes, because I have to write 2 outside it. Okay, and do I need to write SO3 in bracket? No, because there is 1. Wow, you're smart. So, you already know the answers. Look, okay, now today we are going to learn something from this. While writing a chemical equation, we need to know few things. The very first thing that we discussed at the start of this lecture, we should know their states, like whether they are solids, whether they are liquids, uh, whether they are gas, or whether they are in aqueous solution. AQ mean they are in solution form in water. They are soluble in water. Clear? Okay. Okay, the second thing, we must know the number of atoms. So I'm going to take the same example, like these 3 examples, this number 1, number 2, and number 3. Okay, how to calculate number of atoms? Whatever is written at the bottom of letter, that is the number of atom. Okay, let's start from the simplified one. For example, if I'm writing Na2O, how many sodium and how many oxygen? Good, 2 oxygen, 2 sodium and 1 oxygen. Okay, if I write CaCO3, how many atoms and like what atoms? What atoms are present? There is 1 calcium. Oh, so here we need to know something. Whenever there is a capital letter, okay, okay. Shall I say something? Okay, okay. Whenever there is a capital letter, it means it's a new element. It's a new atom. Capital letter means new atom. Okay. So here is calcium and then there is C because it is capital and then there is O. Okay. So there are 3 atoms. Calcium, carbon and oxygen. How many carbon are there? And how many oxygen? Good. Okay, let's discuss the examples. Magnesium nitrate, because we have a bracket here now. No, it's just like a math. Are you good at maths? Yes? I hope you're good. Okay, so in maths, whatever is outside the bracket, we multiply it with the whole bracket, right? So we are going to apply the same formula in chemistry as well. If some number is outside the bracket, we need to multiply that number with all the elements of the bracket. All the elements of the bracket, okay? Okay, let's go to magnesium nitrate. How many magnesium are there? 1, right? Because there's no number with it. How many nitrogen? Think, think more closely. There is a bracket. Bracket is 2. And how many oxygen? 6. Good. This is your answer. Okay, let's talk about the ammonium sulfate. Ammonium sulfate. First of all, tell me what type of atoms are present. You can tell the symbol. You can tell the symbol. N, okay. Hydrogen. Good. We have 4 type of atoms. Now tell me how many atoms are there? How many nitrogen are there? 2. Good. How many hydrogen? Good. How many sulfur? How many oxygen? Good. So this is how we calculate the number of atoms. Okay, why do we need it? Because we have to balance the equation. Now what is meant by balancing? Balancing mean there should be equal number of atoms on both sides of arrows or on both sides of equation or arrow. For example, I'm writing a very simple equation, very simple one. Let's write carbon plus oxygen. Let's write carbon plus oxygen, arrow, sorry, CO2. Now tell me, what do you think? Is this equation balanced? Okay, how many carbon are there on the left side? And how many on the right side? How many carbons are there on the right side? Think again, think again. When there is no number, there is one. Carbon is one on both sides. Okay, oxygen is two on both sides. So, okay, both sides means the left side of arrow and the right side of arrow. Okay, let's move to the left side. On left side, we have one carbon and we have two oxygen that we have written over here. Okay, now let's move to the right side because the chemical reaction has occurred and a new substance is formed, that is carbon dioxide. Now carbon dioxide also has one carbon and two oxygen. So everything is equal. It means this equation is already balanced. Okay? Uh, no, they're not always equal. We have to make the equal. In this equation, they are already equal on both sides. I'm going to write one more equation for you. Let's practice on that. Okay. Hydrogen and oxygen, it makes water. Now, you will find something is unequal. Let's talk about the left side and the right side. How many hydrogen on the left side? Let's write here. 2. And how many oxygen? 2. On this side, how many hydrogen? How many oxygen? Now, it is not balanced, right? Because the number of atoms are different. Now we need to balance it. Now, this is a question of balancing equations. This equation is very simple. You have to like it's a hit and trial method most of the times. Sometimes there is a trick, but sometimes it's a hit and trial method. Okay, so we need two oxygens here, right? What is the easiest way to multiply this whole thing with 2? Now, yes, this is possible. This is possible. We can multiply. This becomes 2, but this becomes 4. Now the equation is not balanced again. We can come to this side. Okay, can we write 2 over here? Is this balanced now? So this is how you balance this. 2H2 plus O2 gives 2H2. Okay. Whenever there is this is a simple equation, you can do it easily, but whenever there is a complicated one, then what we need to do, we need to first of all balance the metals. Okay, if they are given. And the last number is of hydrogen. Metals, then if any other non-metal present or metal present, and at the end you have to balance the hydrogen. Okay, this is the general rule that we follow in balancing. Though you won't have the difficult one, you will definitely be having like easy ones. Won't be that much difficult. Okay, let me give you one more equation. It's a tricky one. Let's apply it. Let me change my pen as well. Al plus O2. Okay, let's move to the simple point first. It makes Al2O3. I won't make you confused. Okay, now you need to tell me how can we balance it. We have to start with metal. Let's, aluminum is a metal. Let's balance it. Okay. What shall I write over here? Sorry. What shall I write over here? Good. Okay. What about oxygen? Here we have 3 oxygen. Here we have 2 oxygen. Now, what is the nearest number that can be like done for them? Do you know about the HCF and LCM? About the highest common factors and the lowest common multiples? Any idea? Okay, okay. So we usually take the HCF over here. Okay. Or the LCMs. We usually apply the LCM. This is the complicated way, by the way. Otherwise, we simply opt for the simple multiple that is nearest to them. 6, 2 and 3. The LCM would be 6. Is it so? Let's make them 6. How to make it 6? This one. O2. Okay. How to make this 3? 6. Put 2 over here. Now, this one is not balanced. The aluminum. What shall we write over here? This is not balanced. How many aluminum are there? 4. So we should write here. Exactly. Is it balanced now? Aluminum 4, oxygen 6. Aluminum 4, oxygen 6. Balanced. Okay? Are you getting it? Understanding it like some to some point, are you understanding it? Even if you are understanding it for 50%, it's perfectly fine for me. 50% is still good. Okay. Now, shall I give you a bit harder one? Okay. NaBr plus Cl2 gives NaCl plus Br2. Okay. How many sodium are here? How many bromine? How many chlorine? 2. How many sodium? 1. How many chlorine? Bromine, sorry. 2. How many chlorine? 1. Okay, now these two are not balanced. Let's balance them. Okay. I'm leaving it to you. Okay. 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 So, what's your answer? It's 2 over here? Okay. You put 2 over here? Okay. So for the it's a compound now. We cannot break it. We have to put 2 before this one. Okay? We cannot put it in between the chemical like compound. And 2 over here. I guess it's balanced now. Just check and tell me, is it balanced now? Okay? It's balanced. Good. Okay. Now, let's move to the which part of this one? Sorry. The type of equations. Okay, this is the general balancing that we will need. Let's move to the type of reactions now. So, generally speaking, there are 2 type of reaction. Generally, Okay, physical and chemical. Okay, physical one, in which no new thing is formed. For example, melting. Water still remains water, right? But in a chemical one, a new substance is formed. For example, hydrogen and oxygen combine together to make water. Carbon plus oxygen gives carbon dioxide. A new substance is formed in a chemical compounds. Okay, let me write this. I'm giving you an example. Like water, it's solid and it's converting into water into liquid. It's still same. And even if it's converting into gas, the substance is same. It's still water, right? So this is a physical change. Whenever there is melting, there is like boiling, freezing. Sorry? Yes, it's a chemical. Okay, how do we say it? A chemical compound is something that is formed by two or more atoms. Okay? Everything is chemical around. We are also chemical. All living and non-living things, all are chemicals. Okay? Okay. Let's talk about the chemical. In chemical one, for example, we have hydrogen and then we have oxygen and it gives us a new thing, which is water. So it's a new substance formed. Okay, this is a simple difference you need to know. Let's talk about the types of chemical reactions. One, two or three we have already discussed. So I'm just jotting it down, like just classifying it. Types of chemical reactions. Number one is combustion. Whenever you hear the word combustion, it means it's the reaction of oxygen with something. Okay? Most of the time with carbon containing compounds. Okay? We call them organic compounds like oils, diesel, petrol. These all are organic compounds. Okay, so the combustion actually releases the heat which runs our engine. Okay, and it produces the combustion of the carbon containing compound and oxygen. It produces the carbon dioxide plus oxygen or water, sorry. So it would be like this. I'm writing a very simple thing, CH4 plus oxygen. It's the LPG or like sorry CNG that we use, the natural gas. The methane. It's a very simple compound, that is a carbon containing compound. It burns in oxygen, produces carbon dioxide and water. This is combustion. How do we define combustion? A reaction of carbon containing compound with oxygen. Okay? Can you define it for me one more time? Okay. Okay. Now, there is a reaction called as combination reaction that we have done. Carbon and oxygen, it's a combination, right? Combination reaction in which two things combine to make a single one. Let's write. Um, Carbon plus oxygen. It gives carbon dioxide. It's a combination reaction. Hydrogen plus oxygen combine to make one compound which is water. It's a combination reaction. Can you give me any other example if you know? No? Okay. Have you seen magnesium burning? Never? It's as simple as silver color ribbon and when it burns it's a white color light is produced. Never? Never have seen? Okay. Magnesium combines with oxygen to make magnesium oxide. There are many, like you can combine calcium oxide and water. It can make calcium hydroxide. Okay. So if you observe in all these examples, basically two reactants, we call these things reactants. Two reactants are combined together to make one product. Okay? It's a very simple reaction. There is like nothing tough in it. Okay, how do we name it? Now you must know the name of the compounds, right? Okay. Can you tell me the name of the last one? What is its name? How do we name it? CaOH twice. Okay. Calcium. Sorry. What is OH? We have done this here. What is OH here? Yes. Calcium hydroxide. So this is calcium hydroxide. So we should know the name. We should know the balancing, and the third thing that is very important, we should know the correct formula. If our formula is wrong, it means our balancing is completely wrong. Then there is no use of balancing it. If we do not know the correct formula, all is in vain. Okay? Okay. The next type. The next type is the decomposition reactions. Okay. The name indicates decomposition. What do you get from this name? Yeah, decompose means breakdown. Breakdown. So the third one, as we have the combination, so we have the decomposition one. Decomposition, in which one reactant breaks into two or more products. One reactant into two or more products. Okay? Or here we have two or more reactants into one product. Okay, let me change the pen to differentiate it. Okay, the decomposition one. For example, let's talk about water. We can decompose water. Now you can tell me how, in what like products the water will break down into. What are the products of water? It's the opposite of this one. Hydrogen, oxygen. You're getting smart day by day. Okay. Uh, it's the basics. Still, if you know the basics, you are smart. Okay. The next one is, I'm giving you an easy one. Let's give you an easy one. Silver chloride. Now you have to tell me the correct formula. Silver chloride. Chloride. And the formula of chloride is Cl2. Like there are some atoms which we write diatomically, like hydrogen is diatomic. We always write H2. Similar with oxygen, it's O2, right? Nitrogen is always N2. So this chlorine, bromine, iodine, these are also diatomic. We have to write it like Cl2, Br2. If you let me give you another example we have discussed already here. Like here we have written, where is the pen? Okay, Cl2 and Br2, right? When they are alone, they are diatomic. Diatomic means there are two atoms. Okay, they are diatomic molecules. Let me write here. Molecules, which is like O2, H2, Cl2, Br2, I2, N2, F2. What else can be there? Nitrogen, oxygen, then we have, okay, these one are the ones which you must know. Okay, there is one more. Which one is silver? Sorry, I'm saying silver. It's iron sulfate. Okay, Fe. Sorry, Fe. Wait, I don't know what happens with my pen. Let me just choose it one more time. It's FeSO4. Okay. Have we discussed the transition elements? Okay. What is the property of transition elements? Good. Good. Okay. SO3 and SO2. Okay. Now, our task is to, before discussing the next ones, which are the redox one and the other ones, let's balance all these. Let's not pile it up. Let's start from the first equation. Can you balance it? CH4 plus O2. Hmm. Okay, take your time and try to balance it. You have to start from carbon. Your last focus should be hydrogen. Okay? Shall I help you? Okay. Is my screen visible to you? Okay. Okay. What shall I write here? Okay. Where shall I put which number? Okay. Um, here. Okay. And what should be here? Look. Carbon is 1. Carbon is 1. 4 and 4. How many oxygen are here? 2 here and 2 here. So in total there are 4 oxygen. 2 here and 2 here. 2 with carbon dioxide and 2 with water. Is it so? So, okay, okay. That's why I stopped. So we have to make the left side and right side equal. Is it so? The left side and right side. So if we calculate the total of right, only right side, this side, this is the right side. How many oxygen are there? A total right side. 4. So what should we write here? Another 2. Another 2. Simple. Okay, next would be easier for you. We have done this already. This, yeah, we write 2 over here. CH4 plus 2O2 gives CO2 plus 2H2O. Let me just erase and rewrite. Um, I need to erase this only. Okay, so it is balanced now. Okay, can you balance this H2 plus O2 give water? We have done this already. Hmm. Shall I give you, may I give you a hint? Okay. 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 Is it balanced now? Okay. What about next equation? There is one magnesium here, one magnesium here. Two magnesium on, sorry, two oxygen on the left side, but one oxygen on the right side. So what shall I do? I shall put a 2 over here. Now there are two magnesium and then right. Whenever we have to balance, we need to put a number beside it. Okay. Okay, the last one for the combination one. I'll do it. Okay. I'll do it because it's already balanced. Let's see. There is one calcium. There is one calcium. Is it so? There are two hydrogen and then there are two hydrogen because there is two outside the bracket. So how many oxygen are there? Two. So how many are on the left side? One plus one. One with calcium and one with hydrogen. So there are two oxygen. So oxygen is also balanced. So this equation is already balanced. Done? Okay. Now let's move to the decomposition one. Let's balance it. Okay. The first one, we have two hydrogen here and two hydrogen here. Okay, balanced. We have one hydrogen here but two here. Let's put two over here. Okay. Then we put a two over here. So we have four hydrogen and four hydrogen. And there are two oxygen and two oxygen. Balanced? Okay, you have to balance the next one because the last one is a difficult one. I need to balance that. Okay, silver chloride, balance this one. Two, Good. Okay, let's move to the last one. I've told you that we have to start from metal, right? So iron is a metal over here. So there are two. Let's put two over here. Okay, so there is like two iron and two iron. Okay, let's calculate sulfur. How many sulfur on this side? Two. On this side, 1 plus 1, 2. Is it so? 1 plus 1, 2. Let's calculate oxygen. How many oxygen? 8. 2 into 4 is 8. Let's calculate on this side. 3 plus 3 plus 2. How many are they? So this equation is balanced now. Okay, this is how you do it. We have to, okay, if there is metal present, we have to start from metal. And if hydrogen is present, we have to balance hydrogen at the end. This is the rule that we need to follow in general. And if you have two numbers, you can just take an LCM. Like 2 and 3, the LCM is 6. Make both numbers 6. Okay? If there is 2 and 5, what is the common number? 10. Make them 10. This is the easiest way to do this. Okay? Okay. So when we talk about decomposition, because we are not done with the balancing and equations, everything, let's talk about the naming the decomposition, the types of decomposition. The first one, water cannot break easily. You can boil water, would convert into vapors, but it won't decompose easily. So you would need an electric current. Okay? So the decomposition water is electrical decomposition. You would need current over here. Okay? It cannot break on heating at all. It will only vaporize. Okay? Second thing, silver chloride. The easiest way to separate the halogen is the sunlight. So this one is the photochemical, sorry, I'm writing light, photochemical decomposition. What is the meaning of photo? Whenever there is a word photo, photo itself means light. Okay, so in chemistry we use the word photo for light, like photochemical reaction, photolysis, like photosynthesis, right? Photosynthesis is the light reaction. Okay, the last one, here we apply heat, and for heat we use the term thermal. Therm mean heat, like the thermal cups. We have thermal cups, right? The thermal bottles. Those thermal is the word we use for heat. Okay. Now, as we have discussed heat, let's discuss another two types. Two types based on heat. Two type of reactions based on heat. Okay. One is the exothermic. Exo mean outside and therm mean heat. The heat move outside. Like, okay, can you give me an example? Uh, Hot water. Okay. Boiling of water. Hot water. Okay. Let's say not, because boiling is not exothermic itself. Okay. Um, any other example? Because then I have to, I'll be giving very like scientific examples. So heat is given out in the surroundings. Okay. I'm giving you a very common example. Combustion, burning, burning of fuel. This one is exothermic. Okay, because carbon dioxide is released, and production of carbon dioxide is itself the exothermic process. Whenever there is a production of carbon dioxide is exothermic. Okay, because I'm going to give you another example. Respiration. We respire. Our body produces heat. Yes? So our body produces heat by a process known as respiration. When we eat something and our food break down, that breakdown is basically respiration. Okay? Okay, in exothermic, heat is absorbed. I'm giving you common examples. Let's further on we'll discuss the like scientific examples. Sorry, absorbed from the atmosphere, or we can also say heat is taken in. Can you give me a good example for this? Sorry. Good. Very nice. I wasn't expecting this example from you. Photosynthesis. So generally we see that the shade of trees are cool, right? Why they are cool? Because they have taken the heat of the surrounding. That's why the temperature drops. Okay. 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 Let's move to the scientific examples. Okay. Whenever we dissolve sodium hydroxide, now this one is like pure chemistry example. Sodium hydroxide. Do you have labs at school? Have you ever performed an experiment? No, not really. Okay. Okay. Uh, then let me give you a simple example. So we say this one is alkali, that the detergents contain alkali. So usually when we dissolve detergents in water, the water becomes slightly hot. The temperature increases. If you want to do that experiment, you can do. You will feel that if it contains sodium hydroxide or potassium hydroxide, specifically the sodium hydroxide, the temperature rises. Okay, okay, this is the general one. And for endothermic one is the dissolving of ammonium chloride. If you dissolve this salt, it's a specific salt. If you dissolve this salt in water, the water become really, really cool. You will feel the difference that the water become cool. Okay, do you know what are the heat packs and the heat packs and the cold packs? Ever heard of? Ever heard of? Okay. So the heat packs are the one which you basically which increases the temperature, and the cold packs are one which decreases the temperature when we dissolve water in it. Okay. They usually follow the exothermic and endothermic processes to make them hot or cold. Okay. Let's move into the chemistry of this one because this is the general thing that we have discussed till now. Okay. So what will happen when the temperature rises? The question is, what will happen when the temperature rises? What does this mean? Temperature increase, or what does this mean? Good. Uh, is basically the opposite. Okay. So it means when heat is given out, the energy. Okay. Wait. Let me put this into a like simple words. You have something, a lot of something. You have lots of heat. That is your energy. But you are giving it away. Will your energy increase or decrease? Okay. you have a lot of energy in your hands, but you cannot hold it. You want to give it to someone else. What happened to that energy that is in your hand if you have given it to someone? It would decrease. Were you saying decrease from the start? But I was like, maybe I was thinking it, I was hearing it wrong. Okay, okay. So it would decrease because the heat is given out. The energy is given out in the surrounding. So for the reaction, the energy decrease. If we just make a graph, let's make a graph. Sorry. Okay, let's make a graph for this one. If we make a graph, the energy of the reactants is high, okay? But that energy is given out in the atmosphere. So the products would have lesser energy, okay? So in exothermic reactions, the energy of reactant is more as compared to the product. Shall I say it again? Okay. As the energy is given out into the surrounding, so the energy of reactants decreases. Okay? This is the general thing that we say about this reaction. Now what will happen to energy in actual? So first of all, when the reaction takes place, the temperature of the system rises. You will feel that the system would have a greater energy. But with passage of time, that system will lose energy and the products would have lesser energy. So overall, there is decrease in energy. Okay? Okay. For endothermic, because they are taking in heat, though the temperature is less, but they are taking in heat. How do we define it? The heat is taken in or heat is absorbed. Sorry. So it means that the uh, products would have more energy as compared to the reactants. Is it so? Okay, let's just make a graph. The energy of reactant is less, but they absorb energy from the atmosphere or the surrounding. So the products would have more energy and there is increase in energy. Okay? So these are the two graphs that you must know. Okay, let's have a general recap of what we have done today. Do you have any question related to this exothermic and endothermic? Okay, in endothermic, heat is taken in or energy is taken in. Okay, so the products would have more energy. So generally, the reactants have lesser energy as compared to the product. Okay, there is one more term in this one because it's getting like so much, so I have missed that term. Do you have any idea about the potential energy? Let's, okay, what is that? Then we can discuss it now. Okay, yes. So this one is the stored energy for this one. Okay, the energy that rises above a certain level. The difference between product and reactant is the you can say the thermal energy that we will discuss later because it's a complete law. But the energy that increases a bit higher, that one is the potential energy. In in simple words for simple understanding. Okay? So what we have done today, we have learned how to calculate the number of atoms. I'll share the PDF with you. I'll share this PDF, okay? And then we'll discuss how to calculate number of atoms. Then we try to learn the balancing of equations by applying the simple rules. We haven't practiced the difficult one. We have just practiced the simple one. Then we have learned about two type of chemical reactions. The first one is the combination reaction and the second one is the decomposition reaction. So this combustion is also decomposition reaction. What's missing from here? Okay. Uh, and at the end, what we have learned the exothermic and endothermic reactions. Okay. Okay. Do you have any question related to this? Okay. Do ask me. We have lesson tomorrow for biology, but you can ask me if you have any question. Okay. Related to this. Related to this. Okay. So today was chemical reaction. Let me send you this file and see you tomorrow with bio lesson. Okay. Bye. Goodbye.